Hello class, welcome to our lesson today dealing with section 5.3. This deals with the sum and difference identities for just the cosine equations. What you want to look at is on your paper of all of the identities, there should be a set that says sum and difference. Now I've separated the two equations for cosine, but you'll notice in your sum and difference equation, or formulas, there's like a plus minus, and then in the second half is a minus plus. I split those up here so you can see them to make sure we're clear about if this first part is a plus here, it's a minus, and if it's a minus here, it's a plus. And what you want to look at is dealing with, okay, if it's cosine of two things, it's going to be cosine of A times cosine of B minus sine of A times sine of B. Now let's go through kind of historically why this would have been important in different stages. Okay, so the first type of question is dealing with exact value. Now exact value questions, remember, are things dealing with 30, 60, 90s, 45, 45, 90s. Now up until this point, everything that we've always done has either been a 30, a 60, a 45, or a 90, or some multiple of that going around the circle. What happens here is you can do things like 15 degrees using the same information by doing the difference of 45 and 30. So pi over 12 is the same as 15 degrees, which I can rewrite 15 as 45 minus 30. I could have used 60 minus 45 and got the same answer. That just uses the formula from the previous slide in saying, okay, it's cosine of the first times cosine of the second. If it's minus here, it'll be plus, and then sine of the first, sine of the second. And it's just a matter of using your right triangles and your 30, 60, 90s, 45, 45, 90s in order to find the answer. This answer ends up being root 6 plus root 2 over 4. Now, historically, that would have been pretty important because there were no calculators for a while. With calculators now, it's less of an issue. So I really don't focus on that type of question very much. Instead, we're going to focus on a different style of question that requires you to use the formulas in a different way. So questions will be like this. They'll give you information that says cosine of S equals something, cosine of T equals something, and in this question they say they're both in quadrant 3. So for S, I draw a triangle, remember always with the x-axis in quadrant 3. -8 is adjacent, 17 is the hypotenuse. I do Pythagorean theorem, I get -15 for the y value, or the opposite. Same thing here, this is a 3, 4, 5 for t, but -3 over 5, and then -4 would be the y value. From there, I don't need to know anything about angles, I don't worry about the angles, I just do the ratios. So cosine of S, -8 over 17. Cosine of t, -3 over 5. Excuse me, looking at the wrong one there. Since it was plus here, I'm looking for cosine of S plus t. I'm going to do subtraction on the right side. Sine of S, -15 over 17. Sine of t, -4 over 5. I just multiply things together, combine like terms. The denominators here should be the same. I get 24 minus the 60, -36 over 85. Your questions are going to be more like that because that actually requires you to use the formula in some way instead of just being able to plug in, say, the angle to a calculator. The other thing that could happen is you get the same question but with a minus. So notice here the only difference is instead of cosine of S plus t like this one had, this one is cosine of S minus t. Everything is the exact same. So if you're showing your work and you're doing those things, the only difference here is that it's a minus in the question, which means it's a plus in the answer. That's just the formula from the worksheet, okay, or from the identities page or earlier in the slides. So the only difference is instead of 24 minus 60, it's going to be 24 plus 60, and you get 84 out of 85. One thing you might want to make note of is your answer better be between -1 and 1, because the highest and lowest that the cosine function can be is -1 and 1. So that might be something to think about as you're looking at these questions. Okay, other than that, this question uses the same triangles from the previous slide. Okay, so that -8, -15, 17, -3, -4, 5, those two triangles are still the same. It's just the difference was we started with an addition, okay, in between those two things. The next question is an identity, just using the cosine properties. Again, not a whole lot here. Just using the cosine of u plus v or x plus y. So it's cosine of the first times cosine of the second minus sine of the first times sine of the second. The important thing here is cosine of pi over 2 is 0. So that just goes away and you're left with -1 times sine. You don't have a whole lot dealing with those ideas. So the focus is going to be more on those questions from the previous slide. Okay, finally, there's going to be some questions about cofunctions. Remember, sine and cosine are cofunctions, and their angles add up to 90 degrees or they're complementary. So the easier question would be just fill in the blank. So sine of 42 is the same as cosine of 48 degrees. You might have some questions that deal with tangent, cotangent, or secant and cosecant. If there's variables involved, you just combine them together, set them equal to 90, and solve. It's going to be that same process every time as you're looking at them. If you have questions about cofunctions, there's a chart on page 207. It's also on your equations dealing with cofunction identities, so that's another option on your identity paper to find that answer. It's either going to be find the trig function that's the cofunction, find the angle that's dealing with the cofunction, or add together and set equal to 90 and solve for x. So, just to recap, your main focus is on these types of questions where you have to find the answers. You want to be able to move quickly and develop the triangles correctly. So for either of these questions with cosine of sine or s minus t or s plus t, get these triangles set up and then just plug in. Your calculator should help a little bit with simplifying and finding those solutions in most cases as well. Have a good day, everyone.